Well, welcome to 8.5 notes. We're talking about angles of elevation and angles of depression. Well, what we have is an application of some right triangle trigonometry today. And my advice whenever you are working with applications of trigonometry, first you should draw the picture. And then when I say draw a picture, just make a rough sketch. You should just draw a rough sketch of a right triangle. You're going to interpret the given information. You're going to substitute that given information and solve and round your answers appropriately. Make sure your answer answers the question that is being asked. So, the very first thing is we have an angle of elevation. And an angle of elevation measures of an angle that something rises. So if I was to take a look at my right triangle here, the angle of elevation is this angle that rises. It's going to have to be with some sort of ground or some sort of something flat, and they're going to say that you're going to have to take and lift up to find the angle of elevation. So that's the angle that something rises. The angle of depression is the measure of an angle that something falls. So maybe you're looking up here and you have to look below. This could be what I call my line of sight, your horizontal line of sight. And you have to look below to find the angle that something is falling. So again, angle of elevation could be maybe this is my horizontal line. I have to lift my head up to find out something that rises. And what you see is we have the angle of depression and we have my angle of elevation. And if these are parallel lines, which they are, so I have a parallel line, then the angle of depression and the angle of elevation are equal to each other. We studied this in the past. These are what we call alternate interior angles. So that's why they are congruent. So the angle of depression and the angle of elevation are congruent. Let's take a look at our first example. It says a boat is pulling a parasailer. The line to the parasailer is 800 feet long. The angle of elevation from the water is about 25 degrees. How high to the nearest foot is the parasailer? So you could draw you a rough picture if you wanted to. So what we have is we have some boat that's out here on this water. That's traveling this direction. And behind that boat, we have the parasailer. Remember, parasailer is just attached to the boat. So we know that this feet of line, that's 800 feet of line. And it says that the angle of elevation from the water, so here this is 25 degrees. And they're saying how high in the air is the parasailer. So that's going to be the height, that's x. So if I look right here, I've got O and I've got H to the 25 degrees. So this is going to be the sine of 25 degrees is equal to X, the opposite side, over 800. So I need to figure out how high in the air is the parasailer. So we have to cross multiply. So when we cross multiply, we get X is equal to 800 times the sine of 25 degrees. So we'll say 800 sine of 25 degrees on my calculator. We get X is equal to 338.09 feet. It's pretty high. Example number 2. A ship on the ocean surface detects a sunken ship on the ocean floor at an angle of depression of 50 degrees. So if we were to take a look, there's where the ship would be. It's going to be there. We've got an angle of depression. So right here, this angle of depression is 50 degrees. It says the distance between the ship on the surface and the sunken ship is 200 meters. So the distance, 200 meters from the surface of the ship to the sunken ship is right here. That's the distance that we're saying. We're saying we are 200 meters away. Now, carrying on, it says if the ocean floor is level in this area, How far above the ocean floor to the nearest meter is the ship on the surface? So they're wanting me to find x right here. Again, I've got an opposite and I've got a hypotenuse. So I'm going to say the sine of 50 is equal to x over 200. We're going to cross multiply and get that x is 200 times the sine of 50. And 200 sine of 50 is 153 meters, because it said to the nearest meter. Looking at example number 3, it says a pilot sights a life raft at a 26-degree angle of depression. So that's, if I was in a plane, I believe that would be my horizontal line of sight. It says that he has to look down to see the life raft out here in the ocean at a 26-degree angle of depression. And it's telling me that the airplane is 3 kilometers above the ocean. So again, if that's 3 kilometers coming over here, I know that that's 3 kilometers. And it's saying, what is the plane's horizontal distance from the raft? So here it would be my horizontal distance. So if I look, I have an O and I have an A. So it's going to be a tangent problem. So I would say the tangent of 26 degrees, that's my angle, equals 3 over x. Now, this is the first time we've done this in a while. I'm going to cross multiply. We get 3 is equal to x times the tangent of 26 degrees. In order to get x by itself, I have to divide both sides by the tangent of 26 degrees. So divided by the tangent of 26 degrees. So x equals 3 over the tangent of 26. So 3 divided by the tangent of 26 is 6.15 meters, or pardon me, kilometers. I didn't say what to round to, so let's just go on and say what is it to the nearest tenth. So x is about 6.2 kilometers. Our last example is just saying, can you identify and discuss what the angle of elevation is, or the angle of depression here? So if I look at angle 1, this angle 1 right here, that is an angle of depression. And it's from the bird. And I'll say that that's a gull to hot air balloon. Angle 2 is an angle of elevation. From hot air balloon to gull. Angle 4 is an angle of elevation from cliff to hot air. And then angle 3 is an angle of depression from hot air balloon to cliff. Really just important, I just want to make sure that you guys are able to identify the angle of elevation as something that rises, and an angle of depression as something that falls. Those are the notes for today. Please check Schoology for your homework. I wish you guys nothing but the best.